Angles in standard position. An angle on the coordinate plane is in standard position if the vertex is at the origin and one ray is on the positive x-axis. The ray of the x-axis is called the initial side of the angle. The ray that rotates around the center is called the terminal side. So the initial side is always on the x-axis of your standard xy coordinate plane. It's always on the positive side of the x-axis. So your initial side you can see is right here, highlighted going to the right, pointing towards the 0 degrees. And then the terminal side is where the angle ends. So notice this terminal side is being measured this direction counterclockwise, which means we will start recognizing the existence of angles that are larger than 180 degrees, depending on how far the terminal side is rotated from the initial side and which direction is rotated. So speaking of direction, positive angles are the terminal side is rotated counterclockwise. So in the first diagram, we would consider this a positive 120 degree angle because the angle is thinking about it as in terms of a clock, and the clock is running backwards. So it's measured counterclockwise at 120 degrees. Negative angles are measured clockwise. So from the terminal side, if we go clockwise, the way that a clock rotates, that would be considered a negative angle. So that would be a negative 145 degree angle. So the first thing we're going to do here is to practice drawing angles in standard position on a standard XY coordinate plane. So draw an angle with a 215 degree measure. So the first thing we're going to need a set of axes. And we need the initial side, which is always going to be on the x-axis. So I'll highlight that in blue. And then the terminal side. This is a positive angle measuring 215 degrees. So being a positive angle, we're going to go counterclockwise. From the initial side to the y-axis would be 90 degrees. We know that's a right angle. And then if we keep going further, a half rotation would be 180 degrees. We've all heard that 360 degrees is a full rotation, so a half rotation is a 180. If we go to the next axis, that's another 90 degrees from 180. That's actually 270, and that's too far. We only need to go another 35 degrees, and I know that because when I subtract 180 from 215, I get 35 beyond this 180. So I'm just going to estimate how far that is. I'm going to say it's about that far, and then I will draw in my terminal side. So that is about a 215 degree angle. Notice I did highlight which way I'm rotating it because that makes a difference on how it's actually measured. Part B, we're going to do a negative 40 degree angle. So let me draw a set of axes in here. Being negative 40 degrees from the initial side on the x-axis where it always is, I'm going to go clockwise, but I'm not going to go very far because 45 degrees would be halfway between 0 and 90. So I'm not going to quite go halfway. So 40 degrees would be maybe right through here. Again, that's just an estimate, and I'm not going to take a protractor to measure it. So that is about negative 40 degrees. Not very far. So if you think about it, you can actually have angle measures since you can go positive and negative. You can have angle measures where the terminal side could be measured either positively or negatively. Or if you do full rotations, you can have angles that are larger than 360 degrees, or the same angle could be measured negatively as well. So consider the picture over on the right. We have an angle that you can see has been rotated all the way around 360 degrees and then another 120 degrees after that. That would be considered a 480 degree angle. It's 360 plus another 120. So knowing that, we can come up with different angle measures that are larger than 360. Wakeboarding is a combination of surfing, skateboarding, snowboarding, and water skiing. One maneuver involves a 540 degree rotation in the air. Draw an angle in standard position that measures 540 degrees. So if we draw it in standard position, then let's see, I would need a set of axes. So 540 degrees would be, one full rotation is 360. If I add another 90 degrees to 360, I get 450. And if I add another 90 degrees to that, I get 540. So my initial side, of course, would be on the x-axis on the right side, but 540 degrees would end on the x-axis on the left side. So that would represent a 540 degree angle. Draw an angle in standard position that measures 600 degrees. Well, we just did a 540 degree angle, which would be 1.5 rotations. So there's one rotation and then another half. We need to go 600 degrees though. So if we know that's 540, if I subtract 540 from 600, I get 60. So I need to go an additional 60 degrees. So to go an additional 60 degrees might be about, let's say, that far. And then I'll draw in my terminal side. Better draw my initial side too. And there you go. There is a 600 degree angle. So as already said, two or more angles in standard position with the same terminal side can happen. And when that happens, those are called coterminal angles. Right there, coterminal angles. For example, in the picture to the right, we have a terminal side right here. But notice that there are different angle measures that could be used to go to that terminal side. I could go the short route and just go from here to the terminal side, and that would be 60 degrees. Or I could do a complete rotation, 360, and then go the 60 degrees for a 420 degree measure. Or I could go the opposite way. I could do the negative direction. And if I do it that way and end here, then I've gone negative 300 degrees. So different ways to measure the same angle with the same terminal side. A quick way of doing that to figuring out coterminal angles is to take the shortest angle measure, the 360, or any angle measure, the 60 I mean, and add 360 to that, so that will give you a positive coterminal angle. Or you could take the angle measure and subtract 360, meaning you would go counterclockwise, and that would give you a negative coterminal angle. So, on example number 3, find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. So to find the positive measure, let's just take 130 plus 360, and 490 degrees would be a positive coterminal angle. Or we could take 130 minus 360, and negative 230 would be a negative coterminal angle. Same with part B. To do a positive coterminal angle, I could take negative 200 plus 360, and that would be positive 160 degrees. Or I could take negative 200 minus 360, and that would give me negative 560 degrees, and both of those would be coterminal to negative 200 degrees.